and you don't get what you're doing, you can say, help me solve this, and it'll walk you through steps that will help you solve it. Now, it's not the same one, but it's a similar one. You can also say, let's say I'm just guessing, I'm going to guess D. I want to check my answer. Oh, I just happened to get it correct. Well, that's great. So let's say 3. Let's say no, this is not a solution. For this one, I'd have to show work, right? I'd have to substitute in 6 for X, 9 for Y, and see if it's a solution. Um, so I want to do a check. Oh, of course I get it right again. Okay, let's see if this one, I'll check no. Sorry, this is incorrect. Well, now you press done, and you can do a couple of things. You can say, help me solve. You can say, view an example like this. So here's a similar problem, and they'll walk you through each step on how to substitute, simplify, how to get your final answer. Now, once you press closed, oh, that was how you exit. I want to try that again. So you can click along, and there's 15 questions. Up here shows your percent of how accurate you are, and here shows 4 of 15 that you've gotten. Now, if you're done and you want to save it, you want to click Save. Don't click out of this. You click Save, and you can come back and continue it whenever you like. And it will save your results in here, like right now, 26.67% done. And you don't want to click I'm done, because that will submit it to me, and I'll know that you only want 26.67% on your homework. You want to click try again, and again it will take you back in there, and you'll be able to do that. All right, so you should go to your haiku page. Down over here we have a folder titled Digits Chapter 6, and you're going to click on 6.1, What is a system of linear equations in 2 variables? A page like this should pop up, and you are going to click Log in to Digits. So that takes you to My Math Universe. Again, you're going to click the Digits picture down here. You are logging into Digits, and yesterday we logged in. Oh, so I already logged in, so it took me right straight to the page, but you guys take time now to log in. Remember to press enter here past the pop-up window. So how you're going to access any of your assignments or homework assignments or notes is you're going to go up to this to-do list bar up here. Click to do, and there should be a lesson right here, 6.1. This button right here should either say start or continue if you've already pressed it, and you are going to press that. Now on the netbooks, some of them won't just pop up like this right away. You will see a little alert up here that says pop-up window not enabled or something like that. Just click on it and say always allow pop-ups for Pearson. That should take care of the problem. Maybe refresh your screen. So right now you should be seeing on your screen a Digits little logo here, and this is where we're going to start our lesson. So you're going to click the next page down in this corner and watch this video. Throughout today's lesson, we are going to be taking our headphones on and off a lot so you guys can be trained how to use the system. Also, I forgot to tell you that you need to turn to a page in your what we'll call Digits Work Student Companion. You need to go to page 127 for today's lesson. So once you get here, go ahead, and I'm going to pause up here on the smartboard, and you all put on your headphones and play this video. Okay, so once you're done with your video here, you're going to click up here, the launch button, and this is kind of like a warm-up type. And up will come a little animated cartoon and a word problem. So we're going to do this together in the video here today. Normally we might have you watch a video, or we might do it as a class. So today we will do it in the video. Okay, so again, sometimes we will do the launch in a video like today, and sometimes you'll do it on your own. If you're on your own, you can always press this speaker button right here.
At speeds shown in the diagram. Runner 1 starts 4 seconds before runner 2 to make the race more competitive. Will runner 2 pass runner 1? Tell how you know.
And if you press that, as you just heard, someone will play or will read the question out for you. Now you can also I'll press this work it out button down here, and it gives us plenty of room to work out the problem. So this is the exact same question that you'll find on page 127 in your student companion, so you're going to be writing along with me. So we're going to make a chart to tell us when these runners or if these runners will ever cross paths. So over here in the chart, we're going to put time. We're going to put runner 1, and in the third place, we'll put runner 2. Now down the chart, we're going to put, obviously in the time, we're going to put how many seconds have gone by. So our first column will be 1 second, our second column 2 seconds, 3 seconds, 4 seconds, 5, 6, we need to keep going, 7, 8, 9, 10. We'll just go to 10. We'll see if that takes us all the way. Okay, so runner 1, it says runner 1 starts 4 seconds before runner 2. So runner 1 starts, and he's going at a pace of 4 yards a second. So in 1 second, he's gone 4 yards. In 2 seconds, he's gone 8 yards, because 4 plus 4 is 8. In 3 seconds, he's gone 12 yards. You just add 4 each time. 4 seconds, he's gone 16. And the pattern will continue. The runner 2, he doesn't start. He starts 4 seconds after runner 1. So in the first second, he hasn't gone anywhere. He's 0. Second 0. Third second 0. Fourth second 0. And only on the 5th second, he's gone 8 yards because he's running at a speed of 8 yards a second. So then in the 6th second, he's gone 16. Well, now if we continue this pattern, we're going to see at some place they might meet. So if we go back to runner 1, he's gone 20 yards. After 5 seconds, he's gone 24 yards. After 6 seconds, 28 yards. After 7, 32 yards. After 8, 36 yards. After 9, and remember this is only a 40-yard dash, so he's going to get done with this in 10 seconds, gone 40 yards. Well, runner 2 is going to go 24 yards in 7 seconds, and not 38, he passes or meets up with runner 1 in 8 seconds. He's also gone 32 yards. So after 9 seconds, he's gone 40 yards and he's done with the race. So remember, we're asking, will runner 2 pass runner 1? Tell how you know. So did runner 2 pass runner 1? Yes, he did. How do you know? Because in second 9 over here, runner 2 had already gone 40 yards. Runner 1 was still down at 36 yards. And of course, because this is a word problem, we need to answer in complete sentences. So, will runner 2 pass runner 1? Yes, runner 2 will pass runner 1. How do we know? We know because at 9 seconds, runner 2 is done with the race, and I might run out of room, with the race while runner 1 is still at 36 yards. So that is how we know. We're telling how we know. Remember, we're justifying our answer here. Now at the bottom of your page, we need to answer the reflect piece. It says, do you think your method for solving the problem would be practical and easy to use for any race with runners who run at any speed with any head start? Explain. So in that spot, try and think up something that you might write. I'm going to pause here and put up an answer for you. Okay, so I've pulled up what you have on your reflection page, and we're again answering, explain why you think or do not think that this is a very valid way of working out a problem. We're saying this is not a good method, so this method is not practical because sometimes your chart would be huge. What if you had 100 runners, or if your race was 1,000 yards? So your chart would be huge, be too much for us to handle. All right, so now that we are done with our launch, we're going to move on to the next part. So the next part up here, you're going to click on examples. Oh great, we gotta clear this. So here we have our key concept, and today what we're really going to do is click through part 1, 2, and 3 up at the top and kind of tell you how a regular day would maybe go. You're also going to maybe have to follow along in your student companion, but I will pause and tell you which pages these are in. So eventually you all will be doing this without watching any of these videos. You'll just be doing it on your own, clicking through, navigating it all on your own. So our key concept, there's no place for this in your student companion. This might be an example of a problem that we'd work out together, or if you wanted to make a separate note of it. Notice how there's this work it out button down here at the bottom. If you wanted to click that, it would show you the answer to the question. If we go on to part 1, and you might want to navigate this on your own, it says there's a couple charts. And again, like we talked about today, these will be like your smarter balance where you're dragging and dropping things. It says determine whether each of the following representations is a system of linear equations. Over here, we have system of linear equations. Over here, we have not system of equations. So we're going to click, drag, system of equations, is it or isn't it? And we're going to drop it where we think. Well, we know a system is is more than one equation at the same time. So we know every one of these that has 2 equations goes in the section of systems of equations, and everyone that doesn't goes in not a system of equations. And this is really neat because you can check the check button and it's correct, and this guy comes up with the big head and tells you that. So then you move on down here, part 1 of 2. We go on to part 2 of 2. Now this is on page 128 in your student companion. So this is where you would actually take notes. So I'm going to pause here, circle your answer, and check back, see if you get the answer correct. Okay, the correct answers were 2 and 3. You should have circled those. Number 1 is not, or the first one is not, because it only has one equation there. All right, so now we move on to part 2. And it's going to, again, it will be like the part 2 in your student companion, just a little bit different. So is 2, 4 a 2, 4 a solution of each system of equations? Explain your reasoning. And again, we've done this before. We did this earlier this week. You're just substituting 2 in for x and 4 in for y, and you're seeing if it works in both equations. Again, down here, if you wanted it to work it out for you, you could click that and it would show you. Actually, why don't we just do that? Oh, Never mind. I thought that it was the video right here, but I guess it's not. Oh, solution. So solution, it would show you a video of exactly how to work it out. And if you press play,
whether 2, 4 is a solution.
It'll walk you through each step. So that's pretty handy to have. So if we move on to the next part of this, now this should look exactly like the part 2. You're still on page 128 of your student companion. So why don't you right now, I'll pause here and you work this out. Remember, we're substituting 3 in for x and -4 in for y. So also on here, the cool feature is you can press show solution down here and your solution pops up. So if you don't have that yes, 3, -4 is a solution of the system, then you might want to check your work, see where you went wrong. It works for both equations. Now in the last example, the video, if you wanted to scroll through that video and just go to the end to see if you got it right, that'd be perfectly fine. So we'll move on to part 3. And again, part 3 has a little animation feature to it. It's about Florida. Wildlife biologists studied, well, you guys can read this, or you can click this.
Wildlife biologists.
And it'll read it for you. You can click the video. You can watch something about Florida and wildlife biologists, connecting our math problems to the real world. And again, the goal is for you to navigate through this without a video of us talking to you. So let's say you read it and you don't really get how to do the math problem. You can click solution and it will pop up a table for you of exactly what you need, what your variables need to be equal to, and your answer. So now we move on to the next part, part 2, and this should be the same thing that's written on 129 in your student companion. All right, so this might seem like a bit of a stretch here, but we are just going to skip forward and do this one together. Normally, I wouldn't be talking to you, walking you through this, so you would have time to watch those last videos. So first thing we're going to do for all word problems or many word problems is we're going to define our variables. Define variables. I'll just put variable. So we're going to say, what do these variables equal? Well, we want to find the lengths of the two species. So we're comparing length. We're going to say L is equal to length. I always spell length wrong. Length of either the Greenland shark or the spiny dogfish shark. And we're saying that T is equal to time, how much time has gone by. So in this case, it'll be 0.75 centimeters per year or 1.5 centimeters per year. So we're T in time meaning the rate of their growth, how much they're growing over an amount of time. So their initial length, L, is going to be, their total length, L, is going to be their initial length, 37 centimeters, plus their rate of growth, which is 0.75 centimeters per year. Oh, we don't want to put that cm in there. 0.75 T. And that is for the Greenland shark. Now, for the spiny dogfish shark, that total length is going to be their initial length, 22 centimeters, plus how much they grow per year, which is 1.5 centimeters per year, T for time. That's how we're setting up our system of equations. Now, we're not actually even solving this in this case. They just want us to set it up how we could compare the lengths of the two species. So after you're done with your last example, you're going to go up here and you're going to click this link called Close and Check. This just takes us back to our original question at the beginning. What is a system of linear equations? What does it allow you to describe? What does the solution represent? So this is on, if you flip your page, on page 130 in your student companion. And ideally, we would get this done by the end of class, but since the video is so long, I'm going to show you here. You also have solution. The answer to this focus question, what does the system of linear equations allow you to describe? What does the solution of a system represent? A system of linear equations will allow you to describe a situation involving multiple quantities that are changing in relationship from one another. The solution of a system represents the point of intersection of the graphs of the equations. And we've seen tons of examples of these this week where we graph two lines on one set of axes and see where they intersect. So tonight, your homework is going to be posted. Once you're done writing this down, I will show you in front of the class how to get to where your homework assignments are saved. It's in the same spot, if you remember, as you got to this 6.1 lesson. If you do not have internet access, then your homework will be to complete the rest of this page 130, 1 through 5. So if you do not have internet access or there's something wrong with your computer, definitely come with the rest of this page completed tomorrow.